I'm Juha and I'm a hockey player here at USC. I will be going through some physics concepts and examples with you this semester. And remember, just like on the ice, there's no such thing as luck in physics. Just keep your head up and work hard.
Another example of one-dimensional motion is a freely falling body. For example, if you throw an object upward, it will go up and eventually come down. And it only moves in one dimension. So we usually define our y-axis, in this case, to be up. And all these equations that we have for our 1D motion apply to the situation with one difference. Our acceleration is always down due to gravity, and its magnitude is that of acceleration of gravity on Earth, but we have to take into account the negative sign because it's pointing down. Alright, so let's go to this problem. So if you toss a ball upward with a certain initial speed, it falls freely, of course, and reaches a maximum height, h, at time t, after it leaves your hand. So we just throw it up. And the question is, if you throw the ball upward with double the initial speed, what new maximum height does the ball reach? So first of all, we have to find the expression for the maximum height in the general case. And in this question, there is no time involved. So again, we opt for this formula where we don't need it. So let's apply it to our purposes. So v is just the some velocity at some point in the trajectory, v squared, and then the initial speed, v0, plus the acceleration, but now a is minus g, so minus 2g, and x is some altitude, and of course we're talking about y now, so y, and some initial altitude. So let's define the initial altitude to be 0 for simplicity, and the altitude that we are interested in is, of course, at the top of the trajectory, the maximum height. So let's call this y max. And this is, of course, then the v max. And when the ball is at the top of the trajectory, the v max is 0. It stops and starts to fall down again. So from here, we can solve for, or let's arrange this a little bit. So v0 squared equals 2g y max. Simply like that. And from here we can solve the y max. So it's v0 squared divided by 2g. And we see that the altitude increases as a square. So if we double the initial velocity, the altitude will increase 4 times, 2 to the power of 2. So we have 4 times higher when the v0 doubles. And because the initial height, or the height achieved with the certain initial speed was h, so then we have the new maximum height is 4h. And then part B, if we throw the ball upward with double the initial speed as before, how long does it take to reach its new maximum height? Okay, so again we have to find general expression for the time it takes for the ball to climb up. And so we're looking something has t involved, so let's pick the most simple one. And in that case we have v equals v0 minus gt. So t is the time that it takes to reach the top, so and then v is of course the velocity at the top. So velocity at the top is 0. So time that it takes to get there, simply v0 divided by g. And from here we can see if we double the initial velocity, the time it takes to climb to the top doubles as well. So we just have 2t.